Hello learners, today we are discussing chapter 14 Biomolecules of class 12th. After this discussion, you will be able to define the term carbohydrates, classify carbohydrates on the basis of their behavior on hydrolysis, understand the structure of various carbohydrates, appreciate the role of carbohydrates in daily life. Living systems are made up of various complex biomolecules like carbohydrates, proteins, nucleic acid, lipids. Carbohydrates are primarily produced by plants and form a very large group of naturally occurring organic compounds. Examples are cane sugar, glucose, starch. Chemically, the carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones or the compounds which produce such units on hydrolysis. Some of the carbohydrates which are sweet in taste are called sugars. The most common sugar used in our homes is sucrose. On the basis of their behavior on hydrolysis, carbohydrates are classified broadly into three groups. First, monosaccharides, a carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehyde or ketone is called a monosaccharide. Examples are glucose and fructose. Next, oligosaccharides, carbohydrates that yield 2 to 10 monosaccharide units on hydrolysis are called oligosaccharides. Examples are sucrose and maltose. They are further classified as disaccharides, trisaccharides depending upon the number of monosaccharides they provide on hydrolysis. Third, polysaccharides, carbohydrates which yield a large number of monosaccharide units on hydrolysis are called polysaccharides. Examples are starch and cellulose. Monosaccharides are further classified on the basis of number of carbon atoms and the functional group present in them. If a monosaccharide contains an aldehyde group, it is known as an aldose, and if it contains a keto group, it is known as a ketose. Different types of monosaccharides are shown on your screen. Glucose occurs freely in nature as well as in the combined form. It is present in sweet fruits and honey. Let us now discuss preparation and structure of glucose. Preparation of glucose. First, if sucrose is boiled with dilute hydrochloric acid or sulfuric acid in alcoholic solution, glucose and fructose are obtained in equal amounts. Next, commercially glucose is obtained by hydrolysis of starch by boiling it with dilute sulfuric acid at 393 Kelvin under pressure. Let us understand structure of glucose. Glucose is an aldohexose. It is the monomer of many larger carbohydrates, namely starch, cellulose. It was assigned the structure shown on the slide on the basis of these evidences. First, its molecular formula was found to be C6H12O6. Second, on prolonged heating with hydrogen iodide, it forms N-hexane, suggesting that all the 6 carbons are linked in a straight chain. Glucose reacts with hydroxylamine to form an enzyme and adds a molecule of hydrogen cyanide to give cyanohydrin. These reactions confirm the presence of a carbonyl group in glucose. Fourth, on reaction with a mild oxidizing agent like bromine water, it gets oxidized to 6-carbon carboxylic acid, indicating that the carbonyl group is present as an aldehydic group. Fifth, acetylation of glucose with acetic anhydride gives glucose pentaacetate, which confirms the presence of 5 OH groups. Since it exists as a stable compound, 5 OH groups should be attached to different carbon atoms. Sixth, on oxidation with nitric acid, glucose as well as gluconic acid both yield a dicarboxylic acid, saccharic acid, indicating the presence of a primary alcoholic group in glucose. The exact spatial arrangement of different OH groups was given by Fischer. Its configuration is correctly represented as structure first, as you can see on the slide. Glucose is correctly named as D plus glucose. D before the name of glucose represents the configuration, whereas plus represents dextrorotatory nature of the molecule. The letters D or L before the name of any compound indicate the relative configuration of a particular stereoisomer of a compound with respect to configuration of some other compound, configuration of which is known. The structure first of glucose explained most of its properties, but some reactions and facts could not be explained by this structure. First, despite having the aldehyde group, glucose does not give Schiff's test and it does not form the hydrogen sulfide addition product with sodium bisulfite. Second, the pentaacetate of glucose does not react with hydroxylamine, indicating the absence of free CHO group. Third, glucose is found to exist in two different crystalline forms, which are named as alpha and beta. This behavior could not be explained by the open chain structure for glucose. It was proposed that one of the OH group may add to the CHO group and form a cyclic hemiacetal structure. It was found that glucose forms a six-membered ring in which OH at C5 is involved in ring formation. This explains the absence of CHO group and also existence of glucose in two forms, as shown in the slide. These two cyclic forms exist in equilibrium with open chain structure. The cyclic structure of glucose is more correctly represented by Howard's structure as shown in the slide. Fructose. Fructose is an important ketohexose obtained along with glucose by the hydrolysis of disaccharide sucrose. It is a natural monosaccharide found in fruits, honey and vegetables. Fructose also has the molecular formula C6H12O6, and on the basis of its reaction, it was found to contain ketonic functional group at carbon number 2 and 6 carbons in straight chain as in the case of glucose. It is written as D minus fructose. Its open chain structure is also shown in the slide. It also exists in two cyclic forms. The ring thus formed is a 5-membered ring and is named as furanose with analogy to the compound furan. Disaccharides on hydrolysis yield two molecules of either the same or different monosaccharides. The two monosaccharides are joined together by an oxide linkage formed by the loss of water molecule. Such linkage between two monosaccharide units through oxygen atom is called glycosidic linkage. In disaccharides, if the reducing groups of monosaccharides, that is aldehydic or ketonic groups, are bonded, these are non-reducing sugars, example sucrose. On the other hand, sugars in which these functional groups are free are called reducing sugars, for example maltose. Let us now discuss about sucrose. Sucrose on hydrolysis gives equimolar mixture of D plus glucose and D minus fructose. These two monosaccharides are held together by a glycosidic linkage between C1 of alpha D glucose and C2 of beta D fructose. Since the reducing groups of the glucose and fructose are involved in glycosidic bond formation, sucrose is a non-reducing sugar. Lactose, more commonly known as milk sugar, it is composed of beta D galactose and beta D glucose. The linkage is between C1 of galactose and C4 of glucose. Free aldehyde group may be produced at C1 of glucose unit, hence it is also a reducing sugar. Polysaccharides contain a large number of monosaccharide units joined together by glycosidic linkages. Starch is the main storage polysaccharide of plants. It is the most important dietary source for human beings. It is a polymer of alpha glucose and consists of two components, amylose and amylopectin. Amylose is a water-soluble component. It is a long unbranched chain with 200 to 1000 alpha D plus glucose units held together by C1-C4 glycosidic linkage. Amylopectin is insoluble in water and constitutes about 80 to 85% of starch. It is a branched chain polymer of alpha D glucose units in which chain is formed by C1-C4 glycosidic linkage, whereas branching occurs by C1-C6 glycosidic linkage, as shown on your screen. Cellulose occurs exclusively in plants. It is a predominant constituent of cell wall of plant cells. Cellulose is a straight chain polysaccharide composed only of beta D glucose units which are joined by glycosidic linkage between C1 of one glucose unit and C4 of the next glucose unit. Glycogen. The carbohydrates are stored in animal body as glycogen. It is present in liver, muscles and brain. When the body needs glucose, enzymes break the glycogen down to glucose. Carbohydrates are essential for life in both plants and animals. They form a major portion of our food. Honey has been used as traditional medicine for a long time. Carbohydrates are used as storage molecules as starch in plants and glycogen in animals. Cell wall of bacteria and plants is made up of cellulose. We build furniture, etc. from cellulose in form of wood. They provide raw materials for many important industries. To summarize this discussion, let us recall the points discussed. Carbohydrates are optically active polyhydroxyaldehydes or ketones or molecules which provide such units on hydrolysis. They are broadly classified into three groups: monosaccharides, disaccharides and polysaccharides on the basis of their behavior on hydrolysis. Glucose, the most important source of energy for mammals, are obtained from sucrose and starch. Monosaccharides are held together by glycosidic linkages to form disaccharides or polysaccharides. Before we end this discussion, let me leave you with an assignment. Question number 1. Classify the following into monosaccharides and disaccharides: ribose, 2-deoxyribose, maltose, galactose, fructose and lactose. Question number 2. What are the hydrolysis products of sucrose and lactose? Question number 3. What is the basic structural difference between starch and cellulose? I hope you understood all the concepts discussed in this discussion. Hoping to meet you again. Till then, take care.